All right, so I've gone directly to the GeoGebra app to do some explanations of this problem. So the first one here, how many points are in the image? There are an infinite number of points on this image. Yes, there's 8 visible points, but those are just there to help us with labeling and talking about certain concepts. But there's an infinite number of points that aren't labeled on this. I mean, just between point G and H on this segment, I could put an infinite number of points on there. It becomes too complex. So we draw the segment to represent the fact that there are these infinite number of points between G and H. Same thing between B and A, and between B and F. So there's an infinite number of points in this image. Second question there about the segments. Now when we look, we could say yes, there are 12 visible segments on this image because they make up the edges of the cube. But we have to remember that just because it's not visible doesn't mean it doesn't exist. And what is between any 2 points is a segment. So if I think about point C there's a segment from C to A, from C to B, from C to D, from C up to E, from C to F, from C to G, and from C to H. That means there's 7 different segments just from point C. Now, if I went to point D, I would have D to A, D to B, D to C is already there, so then I would go D to E, D to F, D to G, and D to H. That gave me 6 unique new segments. And then if I went, say, to G, I'd already have one from D into C, which means from G I could make 5 unique segments. Then from F, 4 unique segments. E would give me 3 unique segments. H would give me 2 unique segments. B would give me 1 unique segment. And A I wouldn't get any because it's already connected to the other vertices through all the new segments we drew in. And if we add those values from 7 descending down to 0, that gives us 28 actual segments in the image. So I'm going to restart this so that we can have a clean slate again. All right, so the next questions then start to look at, well, do we actually have planes when we look at these 4 points? Now, I can use the plane tool to create it and look at A, B, C, D, but if I look at A, B, C, and D, those 4 points make up the bottom of my cube. And so they're on the same plane because they're on the same side of the cube. So that has to be coplanar. So A, B, C, D, yes. If we get to D, C, F, E, now here's D, C, FE. That one's a little bit harder, so let's use the plane tool. So I'm going to click on the plane tool, and I've got options here, but we'll use the first one, plane through 3 points. So I'm going to click on C, D, and I'll click on point E. And now, okay, that's kind of hard to see, so let's rotate it around. I'm going to go back to my move tool, and I'm going to click and drag, and what do I notice is that my plane is going through point F as well. So that's kind of the cool thing to me is you can actually see in this, when you create the point through those 3 points, everything that it hits. And it's creating that diagonal plane from CD up through FE. All right, so I'm going to restart again. So yes to DCFE. So now let's look at GHCA. So again, I'm going to click on my point. I'm going to do just the first 3 points. It only takes 3. G, H, and here's C. All right, so now let's look. Does A fall in this? Well, if I can look now, here's point A, but here's my plane through those 3 points. A is not on that plane, which means that those 4 points are not coplanar. I can see it pretty easily here. Here's A, here's that plane. They're not in the same place. All right, let's go to the next one. EHD. Well, 3 points that are not on the same line automatically will create a plane. So, but let's look at it. H, and then D. And the reason I want to do this is that some times I want you to pay attention to the shape that makes when I click those 3 points. When I look, EHD, it's making that plane that also would include point A. It's kind of hard to see, so I'm trying to rotate it around. But you can see it really makes up that back face. So even though it's only 3 points, it's making up the entire face that also includes point E. All right, let's reset this. And then last one, DCF. So D to C to F. And what do you notice is that's the same plane as we got with DCFE. So the thing to remember, and this gets to question 4 then, is that even though you can name a plane with 3 non-collinear points, it's still going to make what you could think of as like a sheet across, or like a rectangle that's going in infinite directions. It's not just that little triangle between those 3 points, but you take it the length and the width across. So it's going in all directions. So if we were to draw it, it would look more like a rectangle on paper, but it technically goes on forever. And that's important to recognize. It's not just those 3 points, it's everything to the length and width of it going on infinitely. So DCFE is really the same thing as DCF, and that's important to recognize.